The bus is straight outside the hotel there. Okay, great. So the first speaker this afternoon is Hugge. He's basically a man who needs no introduction.
I don't know.
Welcome him to the stage.
Thanks.
Hugge.
Oh yeah, we're good. Hi, yes, I'm Hugge, or my real name is Fredrik Korsbäck. I work at a couple of companies. I work with networking primarily, but I also work a lot with manipulating people, I guess. That's where I'm a layer 8 architect. So I did this talk like really yesterday in the middle of the night, and I noticed, just as LM said, that there's a lot of new faces here. So I actually had another talk for this first, like a really advanced RPKI talk. But I noticed there was a lot of new people here. So I redid the whole talk and actually going to do BGP edge security for dummies, because I think that is a better alternative than to go deep diving in, for example, RPKI, which is what I would typically talk about when doing conferences this year. And also to celebrate that the EU failed on in Article 11 and 13, this will be presented in the way of memes. So hopefully we can have a few good laughs here after lunch. So we will do BGP security for dummies. And first, we need to ask ourselves, why do we need to care about BGP security? I think most people should be aware that, for example, hijacking, misorientations, and other type of attacks has been much more common these days than before with BGP. BGP is a protocol we use on the internet to exchange routing information. And from history, we kind of just trusted each other and made sure that, yeah, no one is doing anything wrong. So we don't need as much security because we will trust each other. That is not true anymore. We have a lot more players on the internet that is running BGP, that has peerings with each and every one, and which doesn't always have friendly intentions or just simple mistakes. Because even here, if Christian has the most advanced automation in the world, there will still be mistakes made from the ones that doesn't have perfect automation. So these are a couple of cool links. I'm not going to go deep into that, what they are, but hopefully people are aware that this is a problem and it is spreading. In this type of meme here, people probably start out here with almost nothing, no import filters, no export filters, and I'm going to help you through this talk to progress to the last part, which is RPKI origin validation. But there's a few steps you can take along the way to actually come there. And maybe a few of these steps we could actually just stop and be there and be happy about it. So the first, as with any 9 or 12 or 15-step program, you first need to come clean. So am I part of the problem or the solution? And yes, most likely you are. I mean, if you are operating on ASN, which has at least one peer, transit included, you are part of both the problem and the solution. And if you're not, for example, if you sell boxes or transceivers, yeah, then you can probably just go, for example, read up on other memes on honestnetworker.net, which I can recommend, or just go emailing. So step 2 is to do the very, very needful basics. And I have examples here for Juniper and Cisco devices, how you can do this. So I really hope that the slide will be published afterwards, so you can essentially go and just copy-paste everything here. There will be a few commands here which could be useful here. So the first thing you need to do when you start as a new operator, or if you have an operator already and you want to improve something, you should reject bogon ASNs and you should reject bogon prefixes, or Martians as we sometimes call them. So in terms of ASNs, there's a few. Most of them are specified through an RFC why they should be blocked, because they are used for something else. So if you see paths on the internet which has these ASNs, they are mostly malicious paths. So for example, ASPath 0 is not a viable one. We have a couple of, the last 16-bit and 32-bit ASNs. We have documentation ASNs. So all of these can be safely blocked. There has been attacks with, for example, ASPath 0, which has been seen on the internet, which has crashed a few vendor routers. Same if you have an XR-based router. It's the same type of list, but in XR commands instead. So please copy-paste this list and put them in your routers. Then we have bogon prefixes, prefixes which for some reason should not exist on the internet. RFC 1918, I guess, is the easy one to spot. 192, 168, 00-16. There's a couple of other ones which shouldn't be possible to route on the internet either. Same goes for v6. There's a couple of documentation, prefix, private prefixes, stuff like that. So these are more than safe to just block in your border, and as well as to block from customers unless the customer has some kind of weird demand, for example, in a VRF. Then, of course, this doesn't apply. Yes, and also the prefix one for XR. Okay, step 3. I think that the very needful basics also contain small prefixes. I think most people have this already, but if you don't have it, please fix it. And also, I'm not sure, I think it was Quagga routers. Someone tried to do long AS paths, for example, pad with 100 ASNs. This is very, very easy to do because most people do the whole AS path prepending the wrong way. So they put in, or rather it's the operating system that does this differently. For example, if you put in a number, like prepend my ASN this amount of times, but then it suddenly injects the wrong ASN instead of the actual number of prepends. And this differs a little bit. So rejecting long AS paths is a very good thing, especially if you're running like Quagga, which I think was the operating system that crashed when someone announced long AS paths. Okay. So what we want to do, of course, is we want to accept /24s and bigger, but nothing smaller. We should block on the internet from public peers. So both on Junos and Cisco, this is super, super easy. I mean, you just specify the prefix length. This is coming from my routers directly. So we just block from any edge peer. We block anything that is between /25 and /32. Should be easy, okay? I will not spend a lot of time on these steps because these are the easy ones that I think most people have, but if you don't, then just copy paste, okay? Long AS pass, the same thing, very easy to do on both Junos and Cisco. Then comes, which I think maybe not everyone has, and that is to use maximum prefix to your advantage. So, you know, having route leaks, having peers announce you, for example, the full BGP table, that I think happens all the time. But most big ISPs hopefully blocks this and kills the session before this happens, or has a filter of some other sort that blocks this type of things. But it still do happen. And you can see these happening even in bigger networks as well, that you have like a full leak of the full table. So using max prefix to your advantage is actually a very effective tool. So this is also from my routers directly. So this is a peer I have with Facebook over Netnod. And they have stated this is also debated, does this value means what you should have as a prefix limit or the amount of prefixes you announce? Since there is no exact science behind this, we always pad up about 10 to 12% on whatever value is stated here. And this is something that we update on every router every night for every peer we have. So it's not a very complex operation. You just through the API go out and pull out this number. And then as we use Cisco NSO in the back. So it has a service that does maximum prefix updates on every peer and make sure that we are always about 10% above what they have. This is to protect ourselves from big leaks. Because it doesn't necessarily need to be a leak which is the full table, but it could be a small leak also, for example. So having a good, using maximum prefix to your advantage is a very good thing, which has helped us quite many times. And of course, you get a very good feeling when you kill sessions that is leaking 74,000 prefixes over an IXPs. Okay, then comes one of the bigger ones, which is step 5, which is IRR filtering. So this is something that's been debated and it's been on every single NOG. I think there's the debate or discussion or talk about IRR filtering, and it can be hard to actually understand what it is. Because people have talked so much about it that it's hard to tell what is actually the truth nowadays. So what we do know about IRR filtering, this will be the super short version, is that it has a lot of inherent problems. Excessive filtering will most likely affect your routers in a negative way. I know that from very good experience that I have a lot of crashed routers due to this. But it's probably still worth it, at least to do some of it. So, what is the problems? So the first problems with IRR filtering is that it's not really authoritative data. It is kind of truth-ish, because there's so many places where you can register IRR data. Because what it is that you, as an ISP, is supposed to declare what your intentions are with your prefixes. Like, these are the prefixes I own, or that my customers own. So you can declare routes, or you can declare which type of customers you have. And a lot of this is stale data. A lot of these sources are not maintained properly. As it is now, RIPE is probably the ones that has the best data quality, which is good for us since we live in a RIPE region. But for other type of IR sources, this has been a big problem. So one solution is to have, which we'll talk about more later, is to have RPKI data essentially drone out old stale entries. Because in a few of these databases, it is really hard to make changes, because they might not be active maintainer. So what most people are doing right now is to have a shim layer on top of these sources. So I think we typically say there is about 18 IRR sources, but no one wants to speak with all 18. So typically you speak through one of the aggregators, which is essentially 2. And it is rr.entity.net and whois.radb.net. Those are typically the 2 default alternatives which you actually ask for IRR data. For example, the only IRD daemon that I know of which is decently good is IRD4, and that is using either entity or RADB. Okay, but we're not there yet. So the entity RR does some of this drown out with RPKI data, but we're not really there yet. So we still have kind of best effort data into these IR sources. So we need to make the best out of it. Okay, and it's essentially what it is you make a query and you try to figure out which prefixes are this operator allowed to announce, and then you put them into your sessions, like this operator is allowed to announce this and this, but not this. Okay, and also as many people might have experienced, especially big operators, is that excessive filtering will most likely affect your routers in a negative manner. And there's 2 things to this. So big configurations is typically bad for router, especially Junos, which is a monolith, which can take forever and ever to do commits. If you have big configurations, we have configurations which are easily 500,000 lines, and that router gets locked out for 6 minutes before it comes available again to actually do configures in. This might not be a big problem all the time. But I think most vendors have seen this, and most vendors is actually working with this as well. Juniper is also working with this quite heavily into handling this in a different way. Arista, the same thing. I think Peter had a talk here before on how you could do smarter big regexp operations, and smarter AS path lists, and smarter IP lists. They essentially put them outside of the router instead of in the router to turn the whole thing up. Also, heavy regex operation is heavy, as it turns out. This is a PR which we created, or rather that we kind of found out that we had AS path groups which was above 10,000 lines, and that made our RPD just crash, and then the router crash. And if you're frequent on Honest Networker, you know there's a couple of memes out there on that topic. Yeah, here's an example. This is our peering router in Amsterdam. It has 33,000 lines. Takes about 2 to 6 minutes to commit in that, and that is because it needs to essentially do a GCC compile on the whole configuration, which is causing problems. And which is kind of weird because this is just control plane anyway, so it doesn't need to, for example, control a data plane or program a data plane to be able to achieve this. This is just control plane. So it's a bit just an unfortunate design. Okay. So what we actually need from this R data, the thing I think you must have is to filter your customers. And I think, of course, you should filter your customers with RPKI data, but that is not going to happen anytime soon in a big sense. So we probably need IR data in between. So this is, for example, a tool to generate IR data. It's called BGPQ3. It is, in my opinion, the only tool available right now which are decent to do this. For example, what we do with we use Cisco NSO4 or NCS as administration, so it's just calling on BGPQ3 in the back from a service to generate these filters automatically every 4th hour for every customer. So what it does, in this case, is Bredbandskollen, which I used an example because they had a very short record, which was handy in PowerPoint. So what it does is ASBBK is their AS set, so that's IR data. That is something they have created, which they they then have formed 2 prefixes in. So they have put 2 routes in their AS set, which are these 2. And here you can see how it will look like, for example, in a Juniper, and how it will look like in a Cisco, depending on which flags you give to BGP-Q3, what type of configuration you want. So it actually, BGP-Q3 already creates the configuration. It's the same. It can do Nokia, Arista, and even Bird configuration, I believe, automatically, just from the command line. So it's quite nifty. This will, and what will happen here is that you will inherit this into a BGP policy of some sort. Same thing if you, for example, this is, I would say that this you must have on your customers, that you do a per prefix filtering. If you do peering, it might be harder. A few peers can be really, really big. Hurricane Electric has peers with everyone, and they have 180,000 prefixes easily. So those will, of course, put a lot of strain on your routers, so I would not recommend perhaps doing prefix filtering towards big peers. So then AS path filters might be a better choice. So this is, for example, ComHem, which is typically an eyeball network. They do have some downstream ASNs, but not that many. So in this case, we're instead using the AS set, and we want to make sure that we only allow the AS paths that sits behind ComHem on a ComHem peering. So this is the configuration you would need in a Cisco and a Juniper, respectively. And as you can see, these are typically regex operations. And I think, yes, and why this can become a problem is, for example, this is Hurricane Electric. So if you do aggregated prefix lists, you get 161,000 lines of configuration. If you don't aggregate, you get almost 1 million lines. So I can assure you that no router wants that prefix list without causing any type of hiccup. So that's why the AS path filters is better. They are not, of course, as accurate. They will not, for example, if you do misorigination, so you're using an ASN which are valid, you will not catch if they're trying to leak certain prefixes. So it is certainly not perfect, but it is the best thing we have in this aspect for now. And yes, this is typically me doing a commit on Junos 15.1. Okay. If this seems complicated, which I give you to, it might do, and maybe not everyone has, you know, an automation tool in the back, cannot afford to buy NCS, maybe don't know how Python works, maybe don't even know how to configure your router in any other way than a CLI, then of course this method with, you know, automatically updating configuration a couple of times every day might be hard. And this is actually why IXPs comes to place, because IXPs has been bashed quite a lot lately by me, by others, that they need to also be part, or they're also part of both the solution and the problem here through the route servers. So the route servers are very, very handy tools when you connect to an IXP to get the immediate payoff for the port. Because most networks, maybe not the biggest ones, typically pair with the route servers. Eyeball networks typically pair with the route server. Or sorry, content networks typically pair with the route server. So if you set up a session to them, it's quite likely you will get value pretty fast. And here, since we are on the Netnod days here, Netnod has done a very good job. I think there might be a presentation later on recent improvements in this case. But I do know that there is, most IXPs today does actually do IRR data on the route servers, or IRR filtering on the route servers, maybe even RPKI filtering, which I know Netnod is doing. AMSTIX and DKIX are already doing it. So then you get all this automation for free, essentially, which is quite handy. And which is especially handy if you want to pair with weird networks. Okay, cool. Step 6, now it's time to brag a little bit. I don't want to brag about myself, but you should brag about yourself that you have fixed this. So one thing to do it is, for example, to join the Manners program. So Manners is an initiative from ISOC, which stands for Mutually Agreed Norms for Routing Security. It's like a manifest of things you as an ISP should do to look like you are the part, right? This is Svan and Märkning for ISPs, essentially. So one of the things, which it's 4 pillars to Manners. So it's to prevent the propagation of incorrect routing information. If you do IRR filtering, you're doing a decently good job of not propagating incorrect routing information. You should also do prevent traffic with spoof source addresses, which is BCP 214, which is another talk we can have. And number 3 is to facilitate that you can be contacted in case of a problem, which means that you have a working abuse, that you have a working knock, that you have, you know, some way that people actually know how to get in touch with you, maybe a phone number to the knock, essentially. I think most ISPs can validate towards this easily. And also the number 4th is facilitate validation of routing information on a global scale. And this is, of course, having your IRR data updated, but it's also another thing. Okay. And if I'm also, it should be noted that I am one of the, what's called like promoter of manners here in Scandinavia. So I also have stickers from manners. But I think it's a good thing. There is a few Swedish ISPs which has joined, Nordnet Sunet, Telia has joined, and a few others. So I think this could be a very cheap and easy way to show the world that you're actually doing a decent job. Okay, step 7. And that is to do step 4 of the manners concept, which is to facilitate validation. And if you're an ISP and you don't know what you need to do, this is the 4 things you should care about in terms of how to make sure that people can do a good job with your prefixes. And that is to make sure that you know what your autonomous number is, or at least know how to update it, and that it is updated. The route and the route sets and the AS sets, and also the RPKI ROAS. And actually caring about the ROAS is important. And I think I will come to that later, why it's getting more and more important. Maybe more important now than for 2 years ago. And ROA is essentially a cryptographic signature of your prefixes. Okay, step 8. You should, of course, this also goes a little bit in the bragging section, that you should support modern paradigms, such as graceful shutdown, for example, to be able to cause as little downtime for your customers as possible. This was a talk I had last year about graceful shutdown. I will not mention it more than that, but I think it's something you should do. It is super duper easy to implement, and it shouldn't take people more than 5 minutes to get this into the network. Like, really, you shouldn't. Even if you run your network with expect scripts, this shouldn't be hard. Okay, 9 minutes ago. Exactly. Modernize your BGP border, acquire currency. It's the famous meme would said. Okay, now comes the last thing. This was actually, my last version of the talk actually started with this slide, right? And then it was 40 slides after that. Now it's like 3 slides. So this will be the short info on RPKI and what's actually happening. So, any network, this is like a 2-tiered approach, by the way, because when you say RPKI, you typically mean 2 different things, depending on who you talk to. So, if you believe that you have a network, or if you believe that you have something which is important, if you have an important website, a DNS system, or a web shop, or a game, whatever, if you believe it is an important IP address of some reason, then you should probably make sure that either you or the one that operates your LIR actually registers a ROA. Since we typically are ripe people here, it is super duper easy. This is output from the Sunet LIR portal. And we have a couple of prefixes here, which is currently seen on the internet, which all has ROAs registered. But if you want to register a ROA, it will appear here, a prefix, and it will say that you probably don't have one, and then you click in that box, and then you click the wizard, little wizard rod, and then it makes everything for you, and then you were done. So this is also a 5-minute job. The only thing you should be, of course, aware of is that the data is correct, that this is the actual prefix size you wanted to use. If it's a /24, or maybe if it's a /22, but you still would like the availability to announce them as /24s, then you can register a to and from netmask. That is essentially the only choice you have. In other regions, it's much more cumbersome. For example, the ARIN thing, still require a fax, which is, you get almost baffled when you hear it. So this is one part of doing RPKI, that is to register your prefixes. And this is especially for stub networks, then your job kind of ends here. Okay. Then we come to the network part of it. This is what ISPs should do, or rather networks that have some kind of transitive function on the internet. And that is to start filtering on RPKI routes. And this is this is a picture I stole from Cloudflare. It's 3 steps. So first you need to validate ROAs from the rears. The rears is a couple of these, or it's actually these ones. So these, if we translate this into SSL and TLS terms, these are the CAs. There might be more going forward, because not everyone is happy how the rears are handling this. We'll see if we need like alternatives rears or alternative CAs for this, but for now, this is what we're using. All of these are typically automatically integrated into these tools, except the RIN, which you need to, because there's terms of service which you actually need to accept specifically. So all these rears are integrated except RIN, which you need to click on a button and then it gets automatically accepted into the validator. So what's happened here is that you have a validator which does the validation of the prefixes from all the rears. It will transport these validated certificates to your router with RTR, and then the router will be able to build a database on which prefixes are validated, or rather in which state they are validated. Okay, and first you need a validator, of course. So right now I would say there is 3 alternatives. There might be 4. Cloudflare is doing, I'm not sure they're doing something, but it's it's not a complete validator. They have like an RTR thing. But this is the old one, the RIPE NCC. I mostly had problems with it. I think that Fredrik in the back here also says, yes, I also have problems. And I think most others on the internet also had big problems with the RIPE validator. It is quite old, it's written in Java. I had crashes all the time and was eating memory and didn't work. Then the fine people at Netnod Labs, which are actually the ones that actually created the RIPE NC validator from the beginning, made a new one in Rust, I believe. It is a Docker container, so it just works, I guess. It was up running in 5 minutes, and I haven't had a single crash with it since then. There's also an OpenBSD version which is coming, and the fine people here at Netnod, I sponsored from Sunet, IIS also sponsored it to get another client out based on OpenBSD. That is coming out very, very soon with a working client, so hopefully that will also be a viable option. But for now, if anyone wants to do this, I would definitely recommend Routinator from Netnod Labs. And configuring this is super easy because RPKI was actually invented quite a long time ago. So most of the vendors already has been pushed and been bullied into implementing this like 10, 12 years ago. So it's already been there. So this is configuration from a Juniper, and it's it's 6 lines of configuration, then it's done. And if you want to try it out, this is the Nordernet RPKI validator, and it's open for everyone. So if you want to try it, please do. It will probably cope with it. Otherwise I just lock it down, I guess. But so far, I know that a few other networks is using it, and it's working fine. If you want to try it out, please do. It's okay. All right. And then the last step is to implement this into a filter. You need to do something about it. And this is also, I've come to learn that people are a bit unsure what to actually do with this data. So the thing why it has been popularized these days is that we only care about one thing, and that is the invalid ones. As you can see here, I have 3 terms. This is also from a Juniper BGP policy. And the only thing, as you can see, where we do something is on invalid state. So if something is invalid, which means, and if something is supposed to be invalid, which means that there is breaking a valid announcement. And that is the thing we want to solve. For things that are unknown, because as it is today, like 90% of the internet is unknown because they didn't register a ROA. So the only thing we want to make sure is that if someone is doing a valid announcement, for example, Google is doing a valid announcement for their 8888 resolver, we want to make sure that no one can hijack that. So that's why we only care about invalid. So if Telecom Russia tries to announce this, it will be an invalid announcement. And then we will not program it, they will not accept it. However they try to manipulate to get the traffic, we will not accept it. And this would, for example, I guess everyone had read a lot of blog posts regarding the Amazon Route 53 hijack. They could have actually been helped out by this, since they didn't register a ROA for their prefix, but a lot of ISPs were already doing ingress validation and could have blocked that prefix from propagating. So this is what we mean today when we say use RPKI, that you only care about invalids, block the valids, don't care about valids, don't care about unknowns. Because in the original specification or in the original thought is that we only care about valids, that we block invalids and that we block unknown, but that will never happen, right? It will happen at the same day that we turn off IPv4. So I mean, it will never fly. But caring about invalids is actually a viable strategy. So is this just a fad? Can I just ignore it like we did last time? I mean, this was hot shit 10 years ago, and then everyone just ignored it, and then it went away. But can we do it now? Well, I don't think so. For example, Cloudflare, they are deep into this. They have built a massive infrastructure to support like information about RPKI, and they will do strict validation on all of their POPs pretty soon. This is an old blog post, right? So yeah, 20 December 2018. So they've already up to 75% at that time. Also, this email was one of the best emails I got in a long time, which was sent out to the Netnod mailing list, was that the whole AT&T network is doing this. And what is good when this happened is AT&T is so big that all of these operators which were lazy and have a lot of invalids, they just couldn't reach AT&T at all. It was like, yeah, we can't reach AT&T. And AT&T is so big, so they can just like, that sounds like a you problem and not an us problem, which is great, because then after that, after this email went out, like 10% of the invalids on the internet were fixed immediately, because everyone needs to reach AT&T in some way. So it was great, and we will have more big ISPs do this quite soon. Oh yes, there's more, of course. So route servers also do this. M6YOX, DKIX does this today. Netnod is kind of done. I'm trying to find Emil to see if we can see how many days is left before we do this on the Netnod route servers. All the IXP manager-based IXPs is also soon very there, so that we can get this on IXP manager-based IXPs as well. And then we're starting to get almost, a critical point when this will actually work. There is a few other big ISPs. I know Telia Carrier is, for example, soon there. KPN is already there. And if, GTT is also soon there to block this. And when these big operators does this, that's when you actually get value for the money here. And so people should start caring about this. And the next question is, of course, which is if this talk was another half an hour, we could do this. But since I already assume I'm out of time, which I am, which is good timing, I guess, is this worth without path validation? For the people that care about RPKI, you know that there's not a path validation aspect to it. And the short answer is yes. And why is, yeah, we'll talk about that in a bar. A few good sources if you want to read up on this. As I said, I hope that this presentation gets online afterwards so you can just copy-paste things. I think these are the best sites to visit if you're still unsure what I'm talking about. I think actually the FAQ from Mendelnet Labs is one of the best ones available, which answers hopefully all of your questions. And I'm done, and I'm 3 minutes out of time.
Okay, Hugge, that's perfectly timed. I'm afraid we don't really have any time for questions, but you'll be at the social tonight?
Yes!
Okay, thanks Hugge for a great presentation. Thank you.